This is going to be our Q&A video for May 1st. Go back to my title slide. May 1st Q&A. So start off with a couple questions from Algebra 2 Trig. Starting with this one submitted by Anonymous. How do you go from the equation to the one you wrote? So we start with 2 cosine x sine x plus sine x equals 0. And I have factored it into sine x parentheses 2 cosine plus 1. So first off, we need to figure out where the terms are. So terms are anything that's glued together with multiplication. So this is one term, and this is one term. When I factor, I have to take something out of every single term, and it has to be the same thing. So I look for things that they have in common. If they're both even, I can take a 2 out. If they both have an x, I can take an x out. Well, sine of x functions just like a variable. It can be pulled out. So this sine of x gets pulled out in front. All right, so that's why the sine of x goes to the front. All right, then I do a parentheses, and I need to still have 2 terms inside the parentheses that represent these 2 terms before the sine x, or after the sine x was pulled out. So that's where the 2 cosine x and the plus 1 come from. I have to leave something behind here. So I could think of this as a 1 sine x. So 1 times sine x, and then when the sine x comes out, the 1 gets left behind. And now how do we double check that we've done this correct? Well, you distribute it back in. All right, and that's where we would get 2 cosine x sine x from when we distribute it to this term, and this is still just one term because it's all glued together with multiplication, plus 1 times sine of x gets us a sine of x back. All right, and then why are we doing this? Well, once it's factored into these 2 factors here, I can use the zero product property to set them both equal to 0. So I get, sine of x equals 0, and 2 cosine of x plus 1 equals 0, and then I can solve these both because they just have one trig function, very easy to solve. All right, this next question was actually submitted via email. I answered that email, but I figured it'd be good for everybody to hear this question. So when finding the domain of validity, why do you only care if the denominator is opposite and adjacent and not if it's hypotenuse? So this is a question pertaining to trig verification problems. So, you're verifying some identity. And then at the very end, you go back to the original functions and you write out what they represent. So let's just come up with something like sine times cosine. I guess I'll put the thetas in, plus tangent, all divided by cosecant of theta equals something. And we go back and we write what the ratios were for each of these functions. And cosecant is hypotenuse over opposite. All right, but what this question says is that we only care about side lengths that end up in the denominator, for 1. Now, does this hypotenuse count? Yes, but hypotenuse is never 0. So although this hypotenuse counts, these both count, they're never going to be equal to 0, so we're never going to have a domain violation here. But with adjacent and opposite here, we can have domain violations. So the reason I don't care if it's hypotenuse is because, ultimately all we're talking about is triangles, and these triangles will always have a positive real hypotenuse. This is never going to be equal to 0. This is our terminal side that then gets rotated around. And as we rotate it, it's the opposite and the adjacent that change. So say the terminal side ended up over here, Now our adjacent has been flipped to be negative. Our opposite is this length. But right when we hit multiples of 90 degree, one of those side lengths becomes equal to 0. So as I'm rotating my terminal side around and it's totally flat over here, I still have an adjacent that's maybe -1, and my hypotenuse is still 1. We could just even say we were going to fix the hypotenuse to 1. It'll never be anything different. Only opposite and adjacent will change. But opposite and adjacent do have the possibility of going to 0. Here our opposite is equal to 0. And if that's part of this identity, then we can run into situations where we get no solutions, where it doesn't balance because one side becomes just a no solution. And so that's why we care about when the adjacent and the opposite are in the denominator and not the hypotenuse. And then if we see that opposite is in the denominator, we want to exclude values where that cause that to be equal to 0. So that happens at 0, pi, 2 pi, 3 pi, comma, dot, 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 all the way up to n pi. And so what we say is that this, trig function that we're working with is true as long as we don't consider angles that cause parts of the trig function to become unreal. So theta cannot equal n pi, where n is any integer. So that's where that comes from, and that's why we don't care about hypotenuse being in the denominator. There's no angle in this whole thing where the hypotenuse becomes equal to 0. Okay. Question submitted by Algebra 1A. An individual who wishes to be identified as anonymous asked, "How is your dog?" Well, hopefully you've been keeping up on the cannoli calendar. He's doing very well. He's getting lots of good long walks every day with me being stuck at home. And we're working on lots of tricks. He can sit and stay and lie down and give paw very well now. He's pretty barky, so just even going down a flight of stairs, he'll just start barking randomly. He really likes his food. He goes crazy at meal times. He's eating a lot. He's getting bigger. He likes playing with other dogs. He's met my fiance's parents' golden retriever once, and that was really fun. And he's met my sister's little Bichon Shih Tzu mix. At least I think that's what it was. And they're really good friends. So yeah, he's doing good. I only get to sleep about 3 hours at a time though, because he does wake me up a lot. So that's been a struggle, but as he's getting older, that's starting to slowly improve. So thanks for asking about him. It's been really fun to have him during quarantine here. Looking forward to doing lots of fun hikes and stuff over the summer with him. Little cannoli, my buddy. But all right, good questions. That was the last question. College Algebra didn't submit any questions this week. So we'll call that good for this video. Have a good rest of your day.